Welcome to today's Academy Live webcast, Virtual Machines for Research on Windows Azure. Wenming, you now have the floor.
Thank you, Stephanie. My name is Wenming Yi. I am a Research Program Manager at Microsoft Research Connections. And today our topic that we will cover is Windows Azure Virtual Machines for Researchers. So let's get started. Here are some of the learning objectives that we have today. One is that I want you to help you understand that we have a variety of pre-configured virtual machines that are available from the gallery, from our Windows Azure portal. And we want to show you how you can take your own virtual machine from existing VHD or installation from your on-premise and move that onto the cloud. And we're going to show you a couple of examples that is related to science and research. One of the first examples we'll show you as to how to run Microsoft Windows in the cloud, and also having a Visual Studio there, as well as having the RStudio, which is a statistics package tool that you can use and install very easily into a Windows Azure virtual machine. The other example is using Linux. So we'll show you how easy it is to take an existing Linux image and deploy that onto Windows Azure and be able to run iPython Notebook on top of it. iPython Notebook is a web-based tool that allows you to interact with an iPython interface and do programming, including plotting in both 2D and 3D, and that also includes many of the very popular packages, including machine learning and other types of scientific packages that you would normally use. So here's the agenda. We're going to look at something called the infrastructure as a service. So if you're not familiar with the cloud, it goes from actual physical machine and all the way to software as a service that also includes what Microsoft is very good at doing, which is a platform as a service, which you completely abstract out the operating system and lets you focus on your software. So today we will focus on IaaS, which is infrastructure as a service that allows you to run virtual machines in the cloud. And these virtual machines could be either Windows and Linux, as I previously mentioned. That could include any software that you install on those machines. So we'll have almost no difference other than better performance and also more reliable than your on-premise servers. So here are some of the other things that we will mention. One is that show you how to provision a VM in the cloud in just a few clicks of buttons, and how you can deploy Windows and the Linux, how many different types of VMs that we support. We'll also show you the VM gallery, which is supported standard on the Windows Azure portal, as well as something called a VMDepot, which is a community-contributed images. That includes many useful Linux images that we can use for scientific and research purposes. The other topics that we'll cover are the VM sizes, including telling you how many cores you can have in these VMs, what are the properties, and the reliability, and why these VMs are much more reliable than machines that you usually, or servers that you usually run on-premise. The virtual disk images are replicated 3 times and can be also geo-replicated so that in case of any type of disaster, your machine is protected using multiple of these insurance policies. And then in terms of the differences of virtual machine disks and images, we'll go over these topics so that you have some of the key concepts mastered by the end of the presentation. So we also spent about 20 minutes going over showing you some live demos of creating these virtual machines, as well as helping you understand how easy it is to install some of the scientific packages that you can immediately use for your research work. So let me start from the very beginning and talk about the difference between private cloud, your servers or your workstations, and all the ways to software as a service. So on the leftmost, we have a window called the physical machine. These are physical servers that you build. So on-premise, you usually build your own servers, or you have your own laptops or workstations that you would normally use. So if the physical hardware fails, you will have to probably wait days, if not weeks, to have those things repaired. And the next phase is that there was a wave of IT revolution or work that happened, which is virtualization. So that means when you create a machine, it no longer is attached to a physical piece of server hardware. You can move that virtual machine from one machine to another by simply copying it to a second server, or you can even do live migration, which is just moving them to another machine using Hyper-V or other products. So that way, you're simply abstracting away from the hardware. So every time your machine goes down, you wouldn't have to reinstall your machines. You simply take that virtual machine image, move it to a new piece of hardware. That is a one layer of abstraction. So the third window, we're starting to talk about public cloud or private cloud. And in that case, in the case of public cloud, which is infrastructure as a service, we will provide these type of hardware for you in the data center that you can customize yourself by simply going to the Windows Azure portal and selecting the number of cores you want, how much memory you need, and also the networking, and you can configure the firewalls as easily as you normally would in a on-premise server infrastructure. But in this case, it's all software-based, meaning that you don't really care about what is, who provides. You don't have to worry about buying the servers. You simply go into a pay-as-you-go model where you can simply go into a portal, provision machines, and when you're done, you turn them off. You no longer pay for it. And we have a fantastic billing model, which is billed by the minutes, and that is very unique in the industry. So the other thing that gets abstracted away is hardware changes. So if there are new hardware that's available in the data center, and cloud infrastructure really grows very fast, we constantly have new SKUs, and we recently released 50 gigabyte memory instances. Those are A7 instances, and you wouldn't have to do much other than clicking a button on the reconfig and selecting the new type of hardware that you would use. So that abstraction is extremely powerful when it comes to being a system administrator. There's no servers to lift. There's nothing for you to worry about in terms of budgets and hardware cost. So you simply pay for it, and then you instantly have the access to the hardware rather than having to wait to have your hardware shipped and installed in your own data center. So the next level is something called platform as a service, which we're not going to cover today, but this is a fantastic concept for people who want to build scalable software. So the idea is that as any type of scaling solution, first of all, it is stateless, meaning that platform as a service machines don't actually have a hard drive attached to them, or the drives that attach to them are actually temporary storage. So instead what you do is you assume there are no hard drives. You don't write to individual drives. You write to a centralized place. So that way you can simply scale your servers to as many as you like. So the idea of platform as a service is that you focus on your software. You simply write your program, deploy it, and you wouldn't have to worry about anything on that operating system. So I write a program that has a specific methods that I implement. Once I implemented those in terms of OS updates, in terms of other programs that runs on the server, I wouldn't have to worry about it. That's what we call platform as a service. I have a weather forecast service that has been running in the cloud using platform as a service for almost 2 years and never had to worry about patching the OS. And sometimes I use up to 50 machines to do the computation. I never had to worry about having to log into these OSs and I don't have to worry about the underlying hardware fail. And once in a while, I do know the hardware failed because my program tells me that it failed to execute, but all I have to do is to let it automatically swap that out, and I just go about my own business, and it will continue to work. Software as a service is something that we are all familiar with. Instead of targeting developers, this is targeting end users. Software as a service is something that you normally use as your email program or your Office 365 or any software that you simply log in and use. And that could, you could also say that Facebook is software as a service. While platform as a service is supporting you to write scalable software without having to worry about machines in the cloud. And IaaS, or infrastructure as a service, is something that allows you to quickly migrate your existing workload into the cloud, but you're responsible for your own hardware patches. So that's the advantage. So this is what we're going to focus today, and we're going to have a series of these webcasts that will cover some of the more advanced topics that allows you to build really scalable and modern software at the server, at the cloud level. So here is a diagram where we show you how you would be able to manage your servers in the cloud. So for you to get started, we have a web-based portal. You simply go to the management portal. It has a very clean and beautiful interface for you to create virtual machines. So you can create, delete, you can monitor the status, you can change the configuration. It's extremely powerful. It's probably one of the best management portals for cloud services that I have seen. And the other way of interacting with the machines that you created is using scripting languages. So you can use PowerShell, if you're a Windows user, to spin up and turn off machines, attach disks to them. You can deploy things. You can change the configurations. You can turn firewall on and off. You can set them into availability set. You can create a cluster. So scripting is very powerful. And if you think about it, you're simply you can easily create hundreds and thousands of machines and change the configuration to your needs by writing a script. So that was not really possible before. So this is where the power comes when it comes to cloud computing. We also offer a REST-based interface, which means if you're not familiar with any of these programming languages, you can always write your own. So you can write your HTTP calls, and it can be tedious, but on the other hand, it ensures there's 100% interoperability regardless of what language you're using. So the second piece is that we allow you to select the type of machines in terms of the operating system, as well as the size of the machines. So we have extra small, which is a shared core CPU, and you have a small instance, which has one CPU core, and then you have a medium, which has 2, and more memory, and 4, and extra large has 8 cores. We have some new instances which are listed in the next set of slides, which shows you we go up to all the way up to 16 cores with Sandy Bridge cores, and also 128 gigabytes of RAM. So there is a lot of these. So another key concept here is persistent disks. What that really means is that regardless of what happens, and this is very different from your typical experience with a server. So regardless of what happens, that persistent disk sits in the Windows Azure storage, and you mount that remotely. That disk is backed up 3 times, and regardless of what happens, you're going to have at least 1 copy available to you. And you can geo-replicate that. Even if the entire data center fails, you have another data center that has a copy of your hard drive. And you would not be able to do that with your own data center, at least not easily be able to do that. So we'll explain that in a second. Essentially, these are virtual disks that you can attach to your virtual machine, and you can add and remove them. You can format them. Just works like your normal hard drive, except for that they are persistent. And we ensure that they're going to be there regardless of what type of hardware failures it will have. So we guarantee that with something called a SLA, or Service Level Agreement. Here are some of the supported applications through virtual machines. So for a lot of these applications, on-premise applications, we provide virtual machines that have them pre-installed for you. So we have SQL Server all the way up to SQL Server 2012, and we have Windows Server 2008 R2, which I'm actually still using in some of my machines, and all the way up to Windows Server 2012 R2, which is the latest version. We also support SharePoint, which is very, very popular with our customers. And recently we announced support for BizTalk 2010 and 2013. And of course, System Center, which I'm not going to go into too much details today. So on the Linux side, we support SUSE Linux, which is one of my favorite distributions. And also Ubuntu. Ubuntu is probably one of the most popular. And it just turns out that the person that worked on the Ubuntu distribution for Windows Azure lives very close to where I am, which is in Colorado. And he really enjoyed working with Microsoft, and he always tells me that we have more knowledgeable people about Linux than a lot of other companies, turns out. So gallery images that are available. So you can go to the standard Windows Azure gallery image, and you can find these images that you can create a virtual machine from without having to install the software, and it will, in fact, save you a lot of time. So let's talk about the actual virtual machine sizes. The extra small, as I mentioned, it's a shared core, meaning that you may have other people that are using the core, but it's much cheaper. And then you have a small instance, which is a dedicated core that is, for your application. It has twice as much memory as the previous one. And for the medium one, you have 2 cores and 3.5 gig, which is a very considerable amount of resources. And you can attach up to 4 virtual disks, up to 1 terabyte each. So that is normally what I use for a lot of my projects, which is a medium sized instance. When you go up, it goes to 4 and 8. And for some of the new instances that we have, it goes from A5, A6, A7. So those have 2, 4, and 8 cores, respectively. And, of course, the memory also doubles in terms of increment. We have the number of disks you can attach to them is pretty much double the size of the core. So we have some new HPC instances that are coming out that have 16 Sandy Bridge cores and has 128 gigabytes of RAM, as well as you'll be able to attach 16 terabytes. So if you're doing scientific computation, this would be the kind of machines that you probably would be using. So here are some of the common scenarios, use scenarios that I personally see as a very good fit for the cloud, or also I see from our customers. One of the things that you can't reproduce on your local on-premise servers is that it is extremely reliable. We have the SLA that it's equivalent to having only about 4 hours of downtime per year. So that is something that would be very difficult to be able to achieve at your own data center. And we also have this property, I think it's actually the most important property of cloud servers, is that they are always going to be on. And this is fantastic for streaming data and any type of scientific instrument that needs to be able to have a server there to receive the data without losing it. So that's the kind of applications that really needs cloud computing. So it's always going to be on. The network is always going to be there. There's going to be diesel generators and all those other types of backup emergency plans that prevents your servers from going down. There's it will be automatically moved off to new hardware if the hardware fails. So this is really the huge effort that goes behind keeping these data centers running at all times. The first scenario I want to discuss is existing virtual machines. So you can take a VHD or your virtualized server and move it into the cloud. Essentially, on Windows, you sysprep it and you move it into the cloud. On Linux, you have to do a little extra things and install WA agent. It's all documented very well on WindowsAzure.com. And the second piece is a cloud workstation. So this is something that I use very much personally. So I have a laptop that is, it's a fairly powerful machine, but I usually keep it turned off because I really prefer not to burn out the expensive laptop. So all of the hard work, a lot of the hard work actually happens in the cloud. So I simply turn on a cloud workstation, select a number of cores I want, run it for overnight, and once I'm done, I turn it off, and I'm billed only by minutes. So for that, it really prolongs and gives you a lot more flexibility in terms of, having to leave that laptop at work and have it do number crunching or simulations. Instead, you can simply offload it to the cloud, and you can, keep your laptop cool and also prolong its life. The other the other scenario that's getting popular is running a Linux cluster. So we have a lot of customers that do large data processing, and they want to keep a large Linux cluster running at all times. And I've seen that happen, and we have deployment scripts that we'll point you to at the end of the session. The development and test environment. So if I want to test 10 different scenarios with 10 different software configurations, it's very easy for me to simply spin up machines in the cloud. So those are actually one of the most popular scenarios that people use. So I just wanted to use it for a day. I want to test it out, and I want to turn it off. So one of the team that I work with in the open source community is the MinGW64 team, which is a cross-compiler. It's a GCC cross-compiler. So they have to test it on many different environments with different configurations. So I actually provide them with the cloud resources for them to be able to do their project, and they're extremely happy with that flexibility and not having to run these machines in their these volunteers' houses. Instead, you can simply offload it for a while, and there's also nightly regression test that runs through these cloud server that only runs about 8 hours per day. And also another very powerful reason to use the cloud is the fact that there are many domain specialists that are common machine images that are already built for you. So, for example, if I am in machine learning and I have some very difficult experimental software that I want to install, those are the kind of things that you would like to see if someone has done that for you already. So in a VMDepot, there might be machine images that already has these difficult software installations that have done for you so that you don't have to keep doing them yourself or spending a week setting up a machine to do. So especially for things that you have to recompile, perhaps experimental software that you don't really know how to install properly. So here's an image of how you can create a virtual machine from Windows Azure portal. And I do see there are 2 questions that people are asking, and we'll wait until the end to answer the questions. We'll go ahead and try to finish the webcast first. So you simply go to the Windows Azure portal, click on Start, click on New, and select a virtual machine. You can either do a quick create or from the gallery. The gallery is a list of machines that are standard images. So here's a screenshot of that. So you can select from SQL Server, BizTalk, Visual Studio, Java, Oracle, many Linux images, as you see in the next screenshot here. You can see these are all popular Linux distributions that we support, and we update for you. Also, this is the VMDepot, which is user contributed. If you simply search for VMDepot in Bing or Google, you'll be able to find this website. So these are the type of images that you can find that the users have, other users have contributed that may save you a lot of time. Virtual machines availability. Let's talk about how the underlying technology works to make sure that your virtual machines are available and make sure that they don't fail. So there's something called the service level agreement. We offer that at 99.95%, which is equivalent to about 4 hours of downtime per year. So that includes any type of hardware failures. If you buy a server and the hardware fails, you're responsible for fixing it. if you're out of warranty, you will have to go buy a new machine. So in the world of cloud computing, you simply move on, and that would be the hosting company or the cloud computing company that would have to take care of it. The data center failure, if there's any type of network or power failure, we have redundant connections, we have redundant power, we also have redundant data centers. We have 8 data centers worldwide to be able to cover these type of failures that you won't be able to do it yourself. And so also any type of hardware upgrades or anything, even if we upgraded the hardware or if the pricing got changed or it become cheaper, you would be able to do that. You would be able to take advantage of that instantly without having to install your own hardware. VM containers, anything, if your actual VM crashes and a lot of these other things that happens were not covered. For example, if your own operating system is doing something wrong or your application is doing something wrong, that is not covered for the virtual machine part of it. So you'll have to fix your own machines if it's infected by a virus or if it is being hacked or anything else that is not Microsoft's fault. You're responsible for yourself. So I do want to explain something called the fault domain. Fault domain simply means that there's not going to be 2 machines. If they're in 2 different fault domains, they're not going to be on the same rack or the same server. The idea is that if one machine fails, the other machine will continue to run, or the other fault domain will run. And there's something called an update domain. So for example, if we need to update the virtual machine host or operating system, so the underlying virtual machine the host virtual machine that runs all the VMs, if we need to update that, we guarantee we're not going to update these VMs that are in separate update domains. Meaning that if you have 2 machines running, we always guarantee that one of your machines is going to be up and it's going to be running, and we're not going to turn both of them off. So that's how we are able to achieve that 99.95 SLA. So let me get to the slide here. So simply, this is something called the availability set. You can add multiple machines into the same availability set. The idea is that you would be able to use them to load balance these machines or put them in a different fault domains, and so that one of them, make sure that one of them don't die. At least one of them is still running when the other domain, either the hardware fails or it's being updated for OS. So let me help you understand the concept of a virtual disk. So the idea of a virtual disk is something that you attach to a virtual machine that is a virtual resource. It's not your physical hard drive. So that way, we have the ability to make 3 copies of it centralizedly managed without having these fail. So we keep 3 copies of them, and they will be your host, C drive. Essentially, they're going to be your host drive that you use for your operating system. So your entire machine is booting off some remote disk somewhere. And the performance is really good if we guarantee a certain amount of performance. And you can attach up to many disks, including the OS disk to your virtual machine, depending on the size of the VM. So they're going to show up just like a drive that you would normally see. They're not going to be mounted through SMB. They're simply going to show up as a hard drive on your machine. So that is very much the same as you would expect how a server would work. So as you can see, the drive C here is actually a virtual disk. It's remote somewhere, but you couldn't really tell. And there's a temporary storage here, temporary drive, that's the D drive. So that's actually a local drive. So if the machine goes down, if the machine is died, data on that D drive is not backed up. But on the other hand, all the content on the C drive, which is a virtual disk, it will be backed up, and you can geo-replicate that. So as you can see that the drive D is a temporary drive, and it's not a persistent drive. That's what they mean. If anything happens to it, there's no backup of it. But on your operating system drive or any virtual drives that you attach to it, it is. So that's how it works. So, and I do want to quickly mention the ideas of caching. So, if you depending on your workload, whether you do more read or you do a lot of read and write, you can set the cache to essentially memory on your local machine to cache read and write to increase the performance. So now this is the persistent disk story here. So let's just say if your virtual machine dies, the remote virtual disks are in the storage system is still there, which is simply spin up a new machine, mount the disk, and you're back to where you were. So you don't lose anything. So you get, you create a new machine. So that's the nice thing about it. And these images, so let me explain the difference between images and disks. So in the morning session, I didn't quite explain this well, but the idea of an image is something that you can create a disk from. Think of it as like a CD image. So this is an image that you will use to create a disk. So disks are essentially attached to a virtual machine. They are an instance. This is something that you have already installed, just like your hard drive. So that's the idea. So if you want, let's just say, if you want to make, you can create multiple machines from the same OS image, but you can't create multiple, disks from the same disk image. You can't do that because it's a disk. So if you do want to make this disk into an image, you can use a feature called capture. So it does something special and removes all the, specific machine-dependent things, like your host name, your device drivers, and you can recapture that into an image. So that's the difference. So always remember, an image is something you can install on a machine, and a disk is essentially something you have already installed already. So image mobility, you can take your VHD, your virtual hard drive, you can move it between on-premise, as long as you have Hyper-V, and move it around. And let's just say, a few people have asked me, what about VMware? There are utilities out there. You can convert these disks very much easily. So you can have a utility, take a VMware image, convert that into a VHD, and upload it into Windows Azure, which just simply work. Very easy. And bring your own server. So we do want to talk to you about how you would actually go do that. So one of the things that people call out is something called forklift migration. So simply take your VHD, get it off your server, upload it to VHD. And one step you have to do is that you must sysprep it. Essentially, like I would have said, is that you have to prepare an image. You have to remove the OS-specific things, and you create an image. That image will allow you to create more virtual disks in the cloud. And the tool that you would use is CS Upload. And you would go to windowsazure.com to look up all these information that you'll need. So there's a gallery, standard gallery. We have a lot of pre-existing VHDs that you can simply use. We have Linux, we have Windows. You can simply, you can even bring your own Linux if you like. If you don't see your favorite Linux distribution, which I would hardly believe. I think it will cover most of your needs from the standard libraries. If it just happens to be that you want to install that Linux image that we don't have, you can upload your own, and you can also contribute that to the VMDepot. So here's some of the benefits that I want to highlight here. One is that in the cloud, all the machines are incredibly fast in terms of the network. Look at the performance stats down there. I simply ran a speedtest.net, and I was able to get in the orders of 200 megabps on a single core machine. And the upload that's easily 10 times faster than my regular internet connection at home. Probably more than 10 times faster sustained. And you can, we guarantee that type of performance for our drives. So the other thing that's different from your on-premise is that we keep 3 copies of your disks. So that by itself is very valuable because you can have that peace of mind that your machine, when something crashes, your hard drive is backed up. Unless you delete your files, of course. Always on. The high availability is extremely important for some of the server workloads, such as Internet of Things. If you have a lot of streaming data that goes into these data centers, and you have thousands of sensors that need to send the data in, and you have your servers go down, that would become a huge problem in the long run. So in the cloud, we guarantee that service level, and that allows you to really be able to focus on your research work. And in fact, we have a lot of universities that really, really appreciate the high availability, given that their own servers can't achieve nearly as the availability that the commercial clouds can do. And also we have community contributed images, as I showed you, and build by minutes, which is a unique offering in the industry. So I am going to share my desktop and give you a tour of the Windows Azure portal and show you how easy it is to create virtual machines. So let me show my desktop real quick. So if you want to try out Windows Azure, so you want to go to windowsazure.com, and we offer a free trial, and you can test it out. I have a login that I've already logged into the portal, into my own portal. So so this is what you see when you log in using your Live ID, and your Live ID can be your own email address. It doesn't have to be Hotmail or live.com or a Microsoft address. It can be your own, but I do recommend that you create one if you want to use Windows Azure. So the first thing you will see when you log into the portal is on the left-hand side, you'll see a set of services that we offer, and it has a really clean interface. The first thing we offer is something called websites. It allows you to create websites that and not even have to worry about the operating system at all. We're not going to cover that today, but I'm just going to give you a very quick glance of it. So if I create a new one and go to websites and go to gallery, you can see that there's a lot of content management system that we offer. So you can see that you can create a forum, you can create a gallery. If you're doing a lot of web type of stuff, websites is for you. So virtual machines is really for people who have images and they have, software that they want to run that are not necessarily web-based. It's more about server-related content, or maybe, that application you will run on your workstation. So this is essentially a machine in the cloud that you would normally be able to log in. So here I have two machines running. One of them is Linux and one of them is Windows with Visual Studio installed. So we'll give you a demo of that later. And also have something called mobile services. Mobile services allows you to quickly create mobile applications that are cloud enabled. So the idea is that you log into a mobile service, create a service, and then it will generate the client code for you that is for iOS, for Android, as well as for Microsoft Windows Phone, and also Microsoft Windows 8. So it will generate these code that calls into the cloud service for you. So that really allows you to very quickly create a scalable cloud service using mobile devices. We're not going to go into that today. And cloud services. Cloud services have two meanings to it. And I'll try to explain that as simple as possible. The simplest way to explain cloud services is a container of compute resources. So, for example, I can have multiple virtual machines in a cloud service, and I can configure various things for that group of machines. I can put them in availability set, which I mentioned earlier for load balancing. I can do VPN. I can add virtual private network that allows you to connect to that group of machines. So essentially a container of a bunch of compute resources. That's what a cloud service is. The other meaning of cloud services that when we first created Windows Azure is something called a platform as a service. The idea is that we have these VMs that are stateless or stateless virtual resources that allows you to run, and you can simply move a slider and it will allow you to create multiple of them because there's no hard drives attached to them. There's no states to keep. So that's the idea of creating a modern scalable application, which is to, you centralize the storage. You use blob storage as a container. You don't read and write to a disk, not even as a virtual disk, because even if you create a virtual disk, every virtual disk is different if you create a different virtual machine. Here we simply say, okay, we don't care anything about writing to the local hard drive. We want to scale. We want to create these machines. They're all the same. And you can create thousands and hundreds of thousands of them, and they all do the same activities, or they all have the same software installed. So this is great for scalable services. But we're not going to go into that today. But it's a topic that we'll cover later, which is very powerful when you want to create modern applications. In SQL Server databases, this is essentially SQL as a service. So that has a way for you to simply create a database. And we also have dedicated servers that you would be able to have really good performance. Storage, let me explain storage. As you can see, I have several storage already created here. Storage allows you to store not only your virtual disks, we also have the concept of blob storage and table storage. So you can go in there and create those type of storage, which are essentially very scalable and distributed. So you can't really have virtual disks mounted on different machines, but here you have objects. They're called objects. So blobs are essentially objects that multiple processes and multiple machines can access these blob resources. That way it really allows you to be able to scale. So it supports virtual disks as well as the concept called objects or blobs that's in the cloud. So HD Insight is essentially Hadoop. That's a Windows Azure implementation of Hadoop. You can create a cluster yourself. You can, by default, it has 4 nodes, and you can create up to probably hundreds of nodes to do number crunching. We also have media services. The Olympics, the London Olympics was actually entirely rendered using media service. It allows you to encode your videos into different formats. Service bus, I do want to explain that feature. It's a persistent messaging system. What that means is that if you want multiple machines want to communicate globally, you have to have a way to persist these messages. So these messages will sit there. They're always going to be there. And servers can take messages and put messages in that service bus queue, which is persistent. Regardless which machine dies or machines come and go, that service is always going to be there. So the idea is that if you want to do distributed computing and you want to communicate, you want to have a classic example is that I have web roles and worker roles. If I want to have web roles that talks to the back end that wants to do some work, so I would put a message in the service bus queue, and the back end workers will take the message out and do the work and put a message back in saying I'm done. So that type of distributed computing is done through service bus. We have Visual Studio Online. You can actually have a web-based interface and write Visual Studio code. Has a lot of the great features of Visual Studio. I'm not going to go into that today either. So there's BizTalk, networking that allows you to do VPN. There's also Active Directory that lets you do authentication. There's a lot of different technologies and services in Windows Azure, and I don't think a single person would be able to master all of them. So I rely on my colleagues to update me on some of the latest technologies, such as Active Directories. So let's actually do an example of virtual machine. So if I want to create a virtual machine, it's very simple. I simply go to New and click on Virtual Machine, and I can go to Gallery. So here are some of the steps. The first step you have to do is to pick an image. So I am a developer, so I really like Visual Studio. So I'm going to create a Visual Studio image in the cloud. So I'm just going to simply pick this. Of course, you have other images available to you, including Linux and other formats. I'm going to simply click on this and click on the next step. The next step is you give it a name, and it has to be global. So no one else can have that name. So I'm going to call it Today Demo 1. Hopefully that name is not taken yet. And I'm going to call my user Remote Admin so that I'm not confused here. And, of course, my favorite password. So once I'm done here, I'm going to click on Next. So now it's going to ask you whether you want to create a cloud service or not. So as we mentioned previously, the cloud service is a container of your virtual machines. When you create a virtual machine, it has to sit in that cloud service. That's kind of a container for your virtual machine, so the outer layer of it. So what I'm going to do is to say, hey, create a new one. I trust that it will create a nice one for me. And then I will put that in East US. And as you can see, that storage gets automatically generated because it's going to understand you want a virtual machine on the East US, and it's going to generate a storage or a virtual disk on the East Coast. Otherwise, we prevent users from having to do something like creating a virtual machine on the East Coast and writing to a disk on the West Coast. That would be incredibly slow. So that is all taken care of for you, and will prevent you from making mistakes like that. So the ports are important. You want to make sure that you would have access to your machine once you create them. So I will have remote desktop enabled as well as PowerShell. So I simply click on Next. As you can see, it's just a few clicks, and I have a virtual machine in the cloud, and I can log in and do Visual Studio, use Visual Studio. So I previously have created a virtual machine here. I'm simply going to click on it. As you can see, there's a few tabs up here. One is called a dashboard. The dashboard tells you what's happening with your virtual machine. So it gives you the name of the machine, how many cores I'm using. So this is a Linux machine, as I can see, because it tells me that SSH details. So let's actually look at a Windows machine here. So a Windows machine is the VS one. If I look at the dashboard here, it doesn't have SSH. It does tell you that the host name, and there's a bunch of configurations you can do, and the subscription ID and among other information. You can also monitor it to look at the what is happening with that virtual machine. Disk read write, make sure that you can monitor it without having to log into the machine. Endpoints, if you want to change, you can go back and do that. Configuration. So if I am regretting that I bought a machine that is too small, I can immediately upgrade it. You can't really do that with your favorite PC manufacturer. Once you bought it, you own it, right? So I can simply say, hey, now I wanted 8-core. I made a mistake. Hey, it's just going to work. So let me actually log into the machine. So how do I log into that machine? So the way it works is you go back to dashboard, and you can see there's a set of tools at the bottom. You can connect to the machine, restart it, shut it down, attach a disk to it. So if I want to attach another hard drive, I simply say attach, and it will just simply show up, and you format the drive. It's pretty easy. And I can capture that image, but I have to shut down the machine before I can capture the image. Otherwise, it's a moving target. So let me connect to the machine, and I am going to simply open that RDP port. So my password is okay. So I am logged in. It will probably take a few seconds for you to see my desktop here. So here, what I have is I have Visual Studio already installed. It installed it for me. So normally it's like a 1-hour process, so I want to install it myself. I also have some scientific software installed, which I use quite often, such as R, which is fantastic for statistics. So let's just say if I want to upload something to the remote machine, let me actually show you a little trick here. I can simply copy a little file here, so you can see that there's a little R file on my local machine. This is on my laptop here. So I can simply drag that into here, or press Control-C. I'm going to press Control-C here, which is to make a copy of it. I'm going to do a Control-P, which is going to copy it to desktop. I already have a version here. I'm simply going to say that don't copy here. But as you can see, if you want to remove something from your this machine to the remote desktop, it's simply a copy and paste. You can also mount your drive remotely. So RDP has amazing features. So I have RStudio already done here. So I already loaded my software. I can simply go to code and run region and run all. You can see that I just run it as a normal workstation. And it's very powerful. And if I don't need it anymore, I just shut it down, turn it off, and you're not getting billed by it. So this is a very easy to use resource once you have access to it. So the second thing I want to show you is to go back to the portal here. I want to show you how to create a Linux virtual machine. So I simply go to New, Gallery again, and go to one of the Ubuntu distributions, or one of our favorites. Just pick one. Okay, I can actually pick OpenSUSE. I just say 3, maybe 4. That would do. Simply core. So you can either upload your SSH keys or you can provide a password. So I'm going to click on Next, and I can create another cloud service. As you can see, that someone already has taken that. I'm going to put a W there, my initial there. So Northern Europe. And also think about, you can actually do this by creating a virtual machine anywhere in the world. So if you have collaborators that are remote, that's really a fantastic way to collaborate by simply create a resource in the cloud, and suddenly it's really the region of your choice there. So in order to log into into SSH, I have a machine that's already been created here. So it's very simple. All I have to do is to open SSH client. So I'm going to make a copy of it here, and I'm going to open Sigwin. So this is my favorite way of doing SSH, but you can use your own. You can do PuTTY and other things. So I can say SSH, right-click and say paste, -L. The default user is Azure user. And there's my password. Look, I simply logged in. The other thing I want to do is to show you that for this particular image, where I actually got this particular image. So it's not one of the stock images. I got that from from the VMDepot. So in order to find that, it's a little hard to find. So those are user community contributed images. So you won't be able to find it in the virtual machines instances page. You have to go to virtual machines, and you have to pay attention here. You have to go to the images tab. So this is a little trick there, which is you have to go to images. So once you go there, you can browse through the VMDepot. So, and here's a list of all the VMs that's there. So here we have quite a few different VMs. So I'm just simply going to copy one of these VMs. So let's just say I really want to use the Azure Data Science Core. I can simply select that and just click on Next. So the idea is that I am shopping from the VMDepot, and I need to copy that image locally in order for people to use it. So I can copy it to a virtual, to West Data Center. That's fine. I simply say OK, and it will start that copying process. Essentially, what I did is I got a copy of it, and I now store it in my local storage. So now I have a copy of the image. So once I have copied it, I would be able to go to virtual machines, go to images, and then I can go to the images folder, and you'll be able to see all these different images that are there. As you can see, I have this one already copied. This one is in progress. This one is I have also copied. And also, if you go to the disks tab, those are the physical disks that are attached to my VMs. In fact, it will tell you, where these machines are attached to. So attached to these VMs, you can see that, right? So disks are attached to a physical machine, and images are something that you can create a disk from. So that's the distinction there. So the other thing I want to show you is to actually run something from the Linux box that I have created here. So this particular Azure Data Analysis VM has a lot of interesting things installed already. So that includes Spark and Shark, which is big data processing. Includes a lot of the interesting things like iPython notebooks, which we're going to demo here. So I already have that process running. Let me actually just double check here. So I have something called iPython notebook, which is a process that runs on the Linux box. If I do a top, I think it is running. So if I go to this little process here, and if I click on play or just run the process, you can see that my Python process is working very hard there. And you can see also that I just did a k-means clustering of some data set that I had. We can try to run something slightly more complex. Go there, go to, I think another good one would be, another good one to run would be, let's see, a species distribution. So let's click on that one. This one takes a little bit longer. So essentially this is as you can see, this is an interactive web-based Python development environment. You will be able to interactively write some code, do some processing, and everything is in the web page. It has 2D plots, and some folks have already gotten 3D plots working. It's a open source project. As you can see, it's working really hard, taking 99% of the CPU here, and 20% of the 5% of the memory. So that really allows you to have a very rich interface to be able to do your scientific work interactively. So right there from your web page there. So if you download that VM image, you will be able to start that running very quickly by simply starting up the server. Just simply type iPython type equals notebook server. So that's all you have to do. So these are all pretty much done for you. Very powerful images that with all the software that have been installed for you rather than having you to do it yourself. And I have a lot of users already using that. So let me go back to the slides. That concludes our demonstration. Let me go back to the PowerPoint slides. So we're going to go review some of the things that we showed you already. So we showed you how to create a Windows VM, and also showed you how to create a Linux VM, right? And then finally, we looked through the platform image gallery, which is a standard one, and as well as the VMDepot. And I showed you it's under virtual machines, then image tab, and then you can find where the machine is. The first step is that you have to copy it onto your local storage account before you would be able to use that image. And there's also a registration process, which is very quick. You simply click on OK, and then you'll be able to use that image and create a machine just like you do from the standard library. We also showed you how to attach a disk, which is very simple. You simply click on attach disk. It will show up on your machine. You format it. Works just the same as you normally would format a drive. So here are some of the things we've learned, just to recap. There's a variety of pre-configured virtual machines available from the gallery. And you can make your own. You can upload your own. You can use CS Upload and the tools. And we have very good documentation on WindowsAzure.com. So you can go on there and do that. We show you an example using a Visual Studio VM that has that. If you have an MSDN subscription, you will be able to see that image. And once I want to repeat that, if you have an MSDN subscription, you'll be able to see and access the virtual machine that has Visual Studio pre-installed, which will save you a lot of time for testing and development. We also showed an example of using Linux and iPython Notebook, which is very popular in education as well as science and research environment. Of course, that we have a lot of examples that are coming up. So building a Linux cluster, go through the labs, show you step by step all the different processes. I think some of this will be available on our training website. If you go to that training website, the training kit will be available. I think it's the 8th of December. You'll be able to download it and kind of learn that process. It will show you step by step how to do all the things that I showed you. And of course, it includes a lot more content, including big data processing, websites, how to use the Windows Azure storage, which you didn't cover, and also HPC. There's tons of content on that. It's a 2-day training class that you would be able to look at on your own. So here are also 2 papers. If you download that PDF file, you'll be able to find these 2 links. So it will go in detail of what I covered today. These 2 technical papers, about 15 pages each, that would essentially walk you through all of this, of what I covered today in much more detail. Like I said, the training content, it's going to be available starting December 8th or perhaps soon after that. So here are some of the links and resources. WindowsAzure.com has all the documentation. You go to the search box and you'll be able to find all the documentation. How do you attach a disk? How do you create a VM? How do you install software? How do I use iPython? How do I use Linux? How do I create a VPN? These are all the questions that gets asked. We also have an Azure for Research program that allows researchers, and exclusively for researchers, that will be awarding them a huge amount of compute resources for absolutely no strings attached from Microsoft Research. If you go to azureforresearch.com, you would be able to find the details of that program. And we're accepting the next wave of requests for proposals. The deadline is December 15th. And if you have any questions, don't hesitate to go to our LinkedIn group, which is Windows Azure for Research group on LinkedIn. There's going to be people that will be able to answer your questions, including technical questions. And you can also always follow me on Twitter, at Wenming Yi on Twitter. I'll be able to answer your questions, and you'll be able to find out the latest of what's happening in Microsoft Research as well as the Windows Azure for Research program. I think that concludes my presentation part of it, and I'll be happy to answer any questions that you may have. So I do see a question, and says, can I use Platform as a Service to build an Android application? Absolutely. This is the server part of it. You can build your server part using Python, using Java, using pretty much anything you want, as long as you've defined your interface properly. And the other possibility is that you can use the Windows Azure Mobile Services. The Windows Azure Mobile Services provides you with all the communication code written for you. So you simply create a mobile service. It will create a database and create some code for you. Once you've done that, it will also automatically generate this client-side code, meaning your Android code has been written for you to communicate with that cloud service. So I hope that answers your question. So if you have any other questions, don't hesitate to ask. I'll be here for a few more minutes.
Okay, great. And if you'd like to, like Wenming said, if you'd like to ask a question, go ahead and stay on. We have enabled our survey. You should see the web page now. Please enter your email address to access the survey questions. We hope you found today's information helpful. If you enjoyed today's webcast or have feedback on how we can provide you with a better event, please let us know by completing this survey. The scores are on a scale of 1 to 5, with 5 being the highest. I'd like to extend a big thank you to our presenter, Wenming, and we'd like to thank you for joining our Academy webcast. You may now disconnect from this call.
Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.